Good evening. We're going to begin the seminar. I'm Tae-sang, today's moderator and the community manager of Labs, 모두의연구소. It's a pleasure to meet you all with Professor Tom Yeh here. You've joined us for Labs' regular seminar, ModuPop, where we share insights on various tech topics, especially AI. Today, we'll be conducting the seminar in English, and this is our first time having a special international speaker. So, who's our speaker for today? Yes, that's right. Professor Yeh contributes significantly to understanding the computations that occur within the model. I hope this seminar will be beneficial for all your studies on deep learning architecture and selecting research topics. Before we start the lecture, you might be curious about what Labs, our company and community, does. Allow me to briefly introduce Labs. Is anyone here first time joining Labs event? Yes, with Professor Yeh, including him. Welcome to our community, those of you who are new and also those of you who are already familiar with our community. Labs is a community and educational company dedicated to serving as a tech research platform based on AI and software. We support research that can be conducted outside the traditional systems, fostering an innovative learning environment that emphasizes proactive learning over competition-driven education. For those of you attending in person here, as you can see on the wall over there, where our CEO is sitting, right over there, our company's mission is share value and grow together. Given the nature of our learning and research community, we strive to promote a culture that values the sharing of knowledge and mutual growth. Thanks to these 9 years of genuine effort, Labs has seen significant growth. Until today, we have hosted a cumulative total of 822 labs with various researchers and developers actively participating. And 60 domestic and international papers have been accepted. Currently, we're collaborating with a wide range of institutions from high-tech companies to non-profit foundations. Our community services are built on 2 main foundations, project-based research labs on the left side and a flipped learning-centered flipped school on the right side. For lab participants, we provide facilities, research paper support programs, and GPU access. Our paper shop program supports research papers by offering up to 2 million Korean won for publications in global top-tier journals. Additionally, we can match you with a corresponding author if needed. We try our best to improve the research environment through these supports. And for Flipped School, it is a self-directed group study where members grow together by teaching each other. It frequently hosts sessions where participants read papers or books together or discuss popular AI lectures. To join our community, you can participate in either the lab or the flipped school. But for a more casual connection, you can join our Slack group, which is linked on our website, or become a member of our LinkedIn or Facebook groups. We try to provide learning opportunities beyond just being a community. First, we offer free tech seminars in Gangnam here and Daejeon. This month, we have presentations on the results from the labs that explored the intersection between art and tech and finance LLM. Secondly, we offer online classes, mostly with the subject with Gen AI, machine learning, and data analysis for beginners. For more in-depth education, we operate the AI School, IFL, and the Software School, Orem Camp. We're currently accepting applications for the schools highlighted in yellow, so we recommend you to recommend them to your friends to apply. We offer AI school education for beginners and also for researchers. If you want to get updated, you can check out our homepage or check out Kakao Talk channel. This is the end of our introduction, but let me notice this. Module Labs offers various programs for free as we are an operating institution of K-High-Tech platform. A satisfaction survey by government through phone will be conducted at the end of the year, so please don't be surprised and please receive the survey call, and we would appreciate it if you answer the call. Thank you, and let me introduce Professor Yeh and give him a big applause. Thank you.
What is the answer of 3 times 2? 6. And all right, so this is 63. So this is 7, and there's a number you cannot see. What is this number? 9. And you're really doing very well. Large language model is trained using very similar method. We cover one number and we ask the model to guess what that number is from the context. So you were able to do this very well. Good job. This is my second summer to spend time in Korea. And this time I want to visit more places. So I asked my friend, where should I visit? And my friend told me, you have to come visit Module Labs. They are doing some really cool stuff. And there's a community of people who really care about AI, who want to learn AI, and you get to meet them. And so I'm meeting all of you today, and thank you for coming. My goal today is to give you a sample of a lecture of what I teach my own students about machine learning and AI, and also some AI technology called RAG, Retrieval Augmented Generation. And I have a very special way of teaching. I like to use my hand and with a pen. And I saw many of you have pen and paper today, so we could practice together. Okay? And I want to mention this is the first time I'm trying the interpretation service, and this is so far it is impressive. Is it right? It is I'm impressed. Hello. Okay. All right. Hello. So first, I want to go through some famous deep learning architectures. First we'll start with a quiz. On the top, they are pictures. It's too bright to see, but there are some pictures. And at the bottom, these are names of the architectures. So this LSTM, GAN, Transformer, RNN, ResNet. So I'd like to quiz my students. Can you match them? And this is like a test. I start with a test. So everybody wakes up. Then, okay? And this is quite hard to do. So let me help you. The first one is Transformer. The second one is Residual Network, ResNet. The third one is hard to see, but it's a generator and discriminator. is GAN, Generative Adversarial Network. And this is really complicated, is this long short-term memory. And last one with this link is a recurrent neural network. So when you take a machine learning class, eventually you learn these architectures and you learn the visual language of each architecture. There's boxes, there's lines, there's some boxes and lines. There are boxes and lines with different colors. And lately, Gen AI is really popular. So the short review of the Gen AI history in terms of images. So in 2015, UNet is the first deep learning model that's able to generate images very successfully. It's from the medical field. And there's CLIP, the first model by OpenAI, to show you can combine images. This I is images, L is language, combine them together. And then the diffusion model came out and to show you could generate really high quality images in high resolution. So if you use DALL-E or Midjourney, these are the US-based AI image generator. In Korea, maybe Cuckoo has an image generator, and then latent DM, add context, add words. And so these are the years. And again, another matching game. So UNet is pretty easy. One of the diagram looks like a letter U. Which one? The second one, right? Okay. So the second one is U, UNet, and CLIP is combining text and images. So this one. And DDPM, LDM is the most complicated one. And this is the most complicated diagram. So it's like this one and this one. So at the end of the semester, I would like usually test my students about this diagram. But it's over time I realized it's very hard to learn this diagram. One reason is every diagram looks like a new language you have to learn. It has unique visual, unique color, and there's not a lot of things they have in common. It's hard to compare the two and spot the difference. Okay? So, and this is an example of a transformer and clip. It will be difficult for you to see this thing is actually an image transformer that you have this architecture because they use different colors and shapes. And also difficult to see what is this input. So is this one number, a vector of numbers, which is, or a matrix, a square, a table of numbers? It's hard to know. And how exactly is this calculation happens here inside the box, and why do you calculate? It's very difficult to tell from this diagram. This diagram tells you the flow, the data flow this way, going through all the different steps, but it does not tell you what the data is. So over the years, I created my favorite way of representing deep learning architecture using these boxes. And these boxes, that each cell is a number you can write, you can calculate, and it becomes very easy. This is the example of showing you have a UNet switch transformer. Do you know Google's model is called Gemini? So switch transformers under Gemini is for Gemini. Sora, OpenAI Sora uses diffusion transformer. And this is GAN. So I have a whole series of this model that if you learn, this means matrix multiplication here. And here you multiply, you get this. And when you read this diagram, it follows the same visual language. This multiply this, you get this. This multiply this, you get this. This multiply this, you get this, and so on. So have this, you could apply your knowledge from one diagram to the other diagram. And so it's been very successful in explaining really wide range of deep learning architectures in my class. And I also study to share on social media and get good response from people. If you could try to follow me on LinkedIn or Twitter, then you will see I've been sharing a lot of posts about this. Today, I want to share with you the matrix multiplication that make everything possible. So when do you learn matrix multiplication? In middle school or high school? High school is golden hagyo, or middle school? Middle school? Do you remember? Or I heard that Korean children, they learn matrix multiplication in kindergarten at Hagwon. Is it true? Or would you be surprised if they are learning matrix multiplication in kindergarten in Hagwon now? Parents pay lots of money. It's possible, right? So that's why when they grow up, they can never remember how matrix multiplication works because it was so long ago. So it's hard for them to remember how to multiply these two matrices unless you just took the exam. So the first question is, what is the size of the output matrix of this? It's 2 by 4 and 2 by 2 times 2 by 4. What is the output here? So the answer is 2 by 4 matrix. And this is the way I like to represent matrix using this form. I stack them in this way. So in this case, you can see the result has to be 2 by 4. If you arrange this matrix this way, you can remember right away. And then also, you can tell the sides, and then you can see the rows and columns, how they match. For instance, this point is the result of matching these two rows and columns. You can see this very easily in this case. So you know, if you take the dot product of this row and this column, you get this value. And then because I draw very big, you can practice actually calculate the number. For instance, how do you calculate this value now? Again, these rows and these columns. So it's 4 times 2, 8. This is minus 21. When you add these two up, you get this value. What is 8 minus 21? What is that? Negative 17, 13, negative 13. Now how about let's do one more. So this is 1 times 2, 1 times 7, and then add it together, you get 9. So you can repeat this, practice, calculate this by hand. But what I think is the most useful property of this, we can stack many matrix multiplication together in a way like this. So in this case, this is a result. We multiply this and this, we get this. Okay? How do we get this? We multiply this and this, we get this. What if we want to have another matrix here? This multiply with this and with this. And once I show my student this, as you stack these matrices up, and I tell them this is how the deep learning neural network calculate as well. 3 layers of neural network. You multiply and multiply again and multiply again. And then, but you also add activation function between the layers and you get your deep learning network. So with that insight, that's how I'm able to present something like UNet. You can see that keep multiplying, becoming smaller, and then becoming bigger again. And you turn this around, it get a U shape. So, and then without this representation, it's hard to stack everything up in just one page. When I designed this exercise, I challenged myself, can I fit everything in one page? So that is the result of the design. Okay, so this is the most basic computation, I wonder how many of you want to know about GPU? You raise your hand, GPU. I can tell you, this also help you understand how GPU work, because GPU can process each cell individually. And then when you design an algorithm for GPU, now if you want to calculate this cell, you put this into a GPU, and GPU says, I need to access some numbers to calculate this. I have a cache. I want to put some data in the cache. And you know, you don't have to provide the GPU, you don't have to give GPU all this number. You only have to give the GPU one rule. Which rule? You want to calculate this one. Only have to give this rule. So that is the essence of how we can have multiple GPU to process really big matrix multiplication in scale. And I forgot to mention, you can scale this up to a really large model. All you have to do is you split this into other small cells. You still follow the same structure of this multiple layers of matrix multiplication. Okay. If you follow the interpretation, can you tell me, is it doing a good job? Good job? All right. So there's, good job. Okay. Okay. Now let's talk about, other than deep learning architecture, I will study to teach deep learning application, a large language model application using the similar approach of by hint. So vector database is a hot topic. Have you worked with vector database? Some of you? Okay. So vector database is often used together with RAG. And so this is my vector database diagram. I show when you have a word here, you can follow embedding, get some numbers, and then you can do some text embedding. So this is a simple, really, really simple neural network with one layer. As I explained, one layer, just you multiply this and get this, and multiply this, and with this, you get this, and combine them, and you project into a smaller, instead of four, these are 4 dimensions, you reduce into 2, and you store them. And when you query, follow the same process, and you take a dot product here, and you get then you get to calculate which, this is a query, which one, there are 3 in the database, which one is most similar to this one. So this is one diagram I can explain the high-level walkthrough of the vector database. And then I can, oh, so this is, okay. Can they see this?
Yes.
Okay. Yeah, so they can ask, can they see the whole screen, right?
Yes, but the text are too small.
Okay, yeah, so this is an overview. I'm actually going to show the larger version of each step right now. And this is a database table. And this part looks very normal, like a SQL table, a traditional database. So you have, or like a Panda table. So you have 3 fields, ID, comment, and user. So how are you, who are you, by John, written by John and Mary. And with vector database is you add one more column. Now I want to add a vector representation of each row calculated from this one. So it's our goal. I want to add a vector of numbers here. And so that is a goal. And to calculate that vector of number, the first step is to compute the word embedding. So we have 3 words, how, and are, and you. So these are English words. I like to convert them into 4 numbers to represent that word. And so usually there's a table like this, we can look up. So how is over here, and 1, 0, 1, 0. So how 1, 0, 1, 0 and go down. So 1, 0, 1, 0 here. R is, where's R? Here. So it's 0, 1, 1, 0. U is here. So 0, 1, 0, 0. So I'm using my hand to perform what the computer will do to look up a word embedding. And this has 4 dimensions. When you build your large language model, you had to pick the dimension for your model, sometimes 512. So you can think of, you can imagine instead of 4, have 512 rows and 512 of these numbers. So, and in this simple exercise, only four numbers. And in this case, just to pay attention to how one word becomes 4 numbers, a vector. And you have 3 words, you have 3 vectors. These are, and the next, I want to combine them into just 1 vector instead of 3 vectors. So I can put the 1 vector in my database. Method number 1 is concatenate. What if I just concatenate this 4 into 3 columns of 4 into 12, 3 times 4. So I can do 1, 0, 0, sorry, not 0. 1, 0, 1, 0, 0, 1, 1, 0, and 0, 1, 0, 0. That's one way. And there's an issue, a problem with this representation. What if you have a longer sentence? What happens if you have a longer sentence? This can get pretty long. What happens? You have 1,000 words in your sentence. So they could be quite long. And so another method is to take an average. So I will average 100, I get 1/3. I average 011, I get 2/3. And this is 2/3. This is 0. And I have that, and then now I can put this number over here. 1/3, 2/3, 2/3, and 0. Okay, so now I have a new value, new vector for the first row. And then I can repeat a similar process. Just repeat this again as review. Who is 1, 0, 0, 0, but I already did the rest. And then combine them is 1, 3, 2, 3, 1, 3, and 0. And so I'll write this 1, 3, 2, 3, 1, 3, and 0. And you can see that there's how are you and who are you. It look like, and in terms of vector, they look almost the same except for the 3rd number. We just need, when we look it up, when we want to retrieve data from our table, we need a way to compare these numbers. You can also compare by looking at which row has the word how, or you can use math to use vector to do the lookup. So that's what the vector database really does. And then this is the last math slide. So now you can enjoy after this. And so to retrieve, we would use dot product. Dot product, if you remember the high school math, it tells you how similar 2 vectors are to each other. You take a dot product. So if we have something that's perpendicular like this, and the dot product is 0. Remember the math? If you have a dot product, 2 vectors like this, the dot product is at 1, very high. And so imagine I have 20 sentences. Each sentence has been combined into these green columns. So these are all the, so if I take a query, we also follow the same process to get 4 numbers. So if we multiply, we turn this query to this and multiply with this. Now you can see this is the way I represent multiplication. This multiply this and this, I get a whole bunch of numbers. These are the output of this number. And these are the end result of dot product. As an example, this is the example. And now I want to find the three most similar for dot product. When similar, is it large? Do we look for something big like max, or do we look for something small or mean as a test? Dot product, I want something similar. Do I take max or do I take mean? Max? 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 Yes, the answer is max. So we'll take max for dot product. And I'll find this number, and this number are the three largest numbers. So, and I will look up 10, return 12, and return ID 15. So imagine we have just more rows here. So return the 15th rows, and 12 rows and 10 rows to be most relevant to the database. So that's how the vector database works. It gives you another way to retrieve data based on the vector similarity. And why is all of a sudden becomes powerful? Because a transformer, the output of the transformer is to convert a word into a vector. And that vector represents a really long sentence. So that is a high-level math, and you probably don't need to do this to build application, but it's nice for you to understand when you use vector database. When you build large language model application, most likely you have to use a vector database to restore sentence embeddings, and then you remember that just bunch of matrix multiplication under the hood. Now I'm going to talk about RAG, the retrieval query. What is it? Retrieval augmented generation. So G, let's think about G, generation. Okay, and so there was the GPT, ChatGPT. What is this G? Is it the same G? Is it the same G, right? Generation. So G. So what does A mean? In English, augment or augmented. Same A as. There's another technology start with letter A. Is it the same A? A? Okay. And what is the simpler word of A? Augment. Augment. Is there a simpler English word for augment? Also start with letter A. Add. So I think I like to just think of it. It's just like this is add, same as add. And retrieval, what is R? R is retrieval. Retrieval. And the math we just did is retrieval. We retrieved the top 3 from the database. Okay? So this is what the RAG is. Or it's more like English. But then when you design a RAG, in my opinion, the thought process is you need a query, you need a prompt, you need a context, and you give all 3 of them, and you add to the LLM, large language model together, is what the RAG is. So I gotta show you what I usually meant by that. First, we have a query. When you type the query to a large language model, so for instance, how much does Tom make? How much money do I make? So this is a query. And when I design the RAG, I'll be thinking about, I have this template. I want to write a text to send to large language model. First, I have a question. I just add the question right here. How much does Tom make? So you write the program to put that question into your template. And then you also design your template to provide some prompting. So prompting is that you add some extra instruction to your large language model. Say, you are a something. You want to be respectful. Also, I want you to be helpful. I want you to be respectful. I want you to be kind, maybe kind. But your answer should not include anything harmful or unethical. So as I'm writing this, I show you how, as a designer of RAG, you will think about how to write this as well. And please ensure your responses are socially, what would be the good word to add? So it's unbiased and positive in nature. So this is how I design this. And as people share this design, the prompt on the internet, you can use as well. And then please answer the following question. And then I want to add context. Where does context come from? Context can come from something you retrieve from the database. So there's a part you can provide some context. So what I would do is that let me use a different color, blue. So use this text to look up the database. Remember the Vector database retrieval? So this, how much does Tom make? We'll turn them into some vectors. And then looked it up, then I find this is the matching data, Tom, 50, Professor. So, and then I can add this Tom, 50, and Professor. Okay, now I finished how a program, computer program, will generate automatically for you, but I just used it by hand to show you how the process. Now you can see three parts, right? Question, you see the context, and you see this. Prompt. How many of you study psychology in college? The memory, we have two different kinds of memories. What are the two different kinds of memories? Long-term and short-term, okay? So the prompt, you can think of it as a short-term memory. And this is a long-term memory that you have to retrieve from another storage. And then this is the question you added together. And at the end, you add the whole text, and you send to a large language model, and they'll get pretty good response. For instance, it'll say something like, Tom made $50. Okay? And because you asked the large language model to be kind, and $50 is a lot of money? Not a lot of money, right? So maybe large language model will say, you are not making much. You need another job. So, and then we'll be able to do something like that, okay? All right, so next is, what if I like to go backward? Let's remove one component one at a time to see how large language model could be worse. So you can appreciate why we need a prompt. For instance, if we remove all the prompt about being kind, being helpful, what large language model might do is we still get the context. 50 Tom Professor is going to do it correctly. It correctly retrieve from a long-term memory. It still have the right question. How much does Tom make? And it will just answer something like $50. No empathy. Okay, just $50. That's it. And what if we remove the context? All it has is just the original question. So there will be just G, no retrieval, no augmentation, right? How much does Tom make? What would large language model say? What do you think? It says something like $25 million. Okay? You might say $25 million. Is this a lot of money? That's a lot of money. And why are you saying that? They make me happy, but it's not true. It makes me happy. I'm happy, but I'm not. I also not happy because it's not true. And so we use the word hallucination a lot to say the model hallucinates when it's saying something is not true. And the model also is using data on the internet. There's a lot of data on the internet to learn this. Why does he think Tom makes $25 million? There's some Tom much more famous than I am. Who's that Tom much more famous than I am, making Mission Impossible and also Top Gun? Tom Cruise. So it's most likely it uses Tom Cruise to make a prediction about the most likely, most probable, the chance is highest, the answer is $25 million. And so now let's go backward. If we add, you don't want your application to hallucinate, you add more long-term memory to the context using a vector database or some other database, and then you want it to be more, acting more like a human. So you add prompt, be helpful, be kind, be respectful. So that is how RAG is, okay? Let's take a moment to, before I go into some advanced RAG, do you have any question? I am trying to be helpful and kind. Okay, so we're going to have a more question answering session. All right, so let's talk about how can we take RAG, the basic RAG, a bit further, some of the advanced RAG techniques. First, let's review RAG one more time. So, it's easier to draw if I lower this down. So I have a person, okay? And this person sent a query to our template. And you might remember what you, instead of sending query directly to a large language model, we send this query up to a database. And then the database retrieve a bunch of documents relevant to the query. For instance, document 12, document 7, document 2. You add some prompt here. So that is RAG. And then the whole text sent to the large language model. Okay? So as a review, the top part is the R, retrieval. And the middle part is the augmentation. We add in two things, context, also prompt, okay? And then the last is, then we do the generation using a large language model. A quick review of how the RAG is using this representation. So one way we can improve is to rank, ask the model to rank before you come up with a final result. So that is called rank GPT. And so the process goes like, you have a user, and you send a query to, again, we don't want to send a query directly to large language model. So we'll send to the database first, and it will retrieve a bunch of documents, 21, 42, and 39. Remember previously, we sent this to large language model, but now we take one extra step. It turns out it improves the performance by a lot. The extra step is now you ask the language model, take this two, please look at the query and look at the document you just retrieved. Please rank them. Please rank. Rate them. And now it says that, oh, I ranked by, this is 2 most relevant. First is relevant to the query, and 3 most relevant to the query. Okay? And then after that, you send this combined result to the larger model. Now the larger model will look at the query, documents, and the prompt together to generate the final answers. And it turns out it improves the again, it improves the performance, because if the query will use the database, vector database, to retrieve the relevant document, it uses just the vectors. And then you also, if you send this document to a large document model, now it can use more logic, higher order reasoning to understand maybe this is more relevant. What if you send everything in the database to large language model to retrieve? You can do that too, but you have to pay OpenAI a lot of money to put everything here. So this is kind of like a shortcut to get this, a small number of documents, 3 instead of 300. And you can send this 3 documents to a large language model to say, can you just rank them again and tell me which one is really relevant to your query? So that's what the rank GPT does. And in implementation, you look at the source code of packages such as LangChain and Llama indexed. You can see the implement rank GPT by writing this prompt, saying that there's a search query, out query. They write the prompt, rank the number of passages, maybe 3 passages. That's what the example we did about based on their. So this I'm going to fill in the blank for you. Let me see, based on their what? Based on their relevance, I think relevance to the search query. The passage should be listed in the descending order. Thank you. So top down. Only respond to ranked results. It's interesting to add one more thing. Do not something. Do not what? Guess. When you design this, one large language model is, sometimes it says a lot of stuff. Let's just keep saying, telling you why the answer is. But in this case, all I want to do is just rank them. I don't want it to tell me, add more stuff. So I said, do not explain. So add do not explain this. Let's go back to here. What if we forgot to add do not explain? So instead of adding 2, 1, 3, they're also going to add your explanation right here, which becomes not necessary. So eventually they decided to add do not explain to the prompt in order to implement rank GPT. Okay? So that is the one way to improve the regular RAG. Another way is this idea called the multi-query retrieval. So in the previous case, we send a single query. So when user said, how much does Tom make? So just one sentence. Okay. And they'll retrieve some document, but then some other question, maybe a more involved question. What are the key issues in Korean presidential election? For instance, there's a query. It's a very tough query to answer. And what are the other ways to ask this question? Maybe I can ask, what are the different parties? What are they representing? And what are the different demographic group, female versus male, old versus young? So there are other questions I can ask. But as a human, I usually just ask one question. And they realize each question can retrieve other information from a database. So multi-query retrieval is, instead of sending queries just to the database, you realize, what if I will send a query to the database, I get some documents, okay? And I'm going to send a query to a large language model, saying, ask the large language model, what other ways to ask this question that is useful? So large language model going to tell you, you can ask another query to query 3, and so on. So now I have multiple queries. And then you use this query to follow the same process to the database, retrieve more documents, say this time 13, 17, 21, 23, for instance. Another query to the database, this time you retrieve 2, 12, 49. Okay? Now you have more documents, more queries. Then you send this entire text to large language model. Hopefully, you can get better answer about Korean election. Okay? And so this is the multi-query retrieval. This is example, again, about the actual implementation. I copied from GitHub. So that's exactly how they wrote in the prompt to implement this multi-query retrieval. You are an AI language model. Your task is to generate, for instance, 3 different versions of the given user question to retrieve relevant documents from a vector database. By generating multiple variations on the user question, your goal is to help the user overcome some of the limitations of vector search. Provide these alternative questions separated by new lines, original question. So that I was just going through, if I am the designer of this RAG application or library, I will think through this and write this almost like an English test. I said, what would be the good word to write there? And I wonder, for instance, maybe I need to add do not explain somewhere. If you test this and you realize it adding explanation to these queries, I want to ask there are many parties because in Korea is a multi-party system instead of one party rules it all, like in China. So for instance, you don't need that. I might ask do not explain to improve the results. So the multi-query retrieval. Okay, there's a pause for a moment. Just put you in a situation. Your boss asks you to improve this. Your boss saw the bill from OpenAI is too high. Why the bill is higher now? Why it costs more to use it? Why is that? What's happening? Yes, we have a lot more document to add here, a lot more context. What are the ways we can save this, save some money? Think about it a little bit. We can try to summarize this document into a smaller document, right? That's very good, very, very good answer. What other ways we can do? So what if we apply the ranking concept? We can ask them to rank them. If after we rank them, what can we do? Keep the top one. Okay? We can also do that. You can start to think about creative way of improving your RAG system by combining different techniques. And so contextual comprehension, contextual compression is the next technique. It's exactly, what's your name again? You just answered your name. Yes, you. Jamie? Yeah, Jamie's answer is contextual compression, what I'd like to talk about. So if we have a user submit a query, and I can send query to database. Similarly, I got a bunch of documents for the context, but I realized if I send this to large language model, kind of expensive. So, and what I can do is, what if I send the query in this, and then as large model say, can you summarize this document with respect to query, keep only a relevant part, and it's going to say, yes, the relevant part of this is, say, this part, maybe this part, and this part, and then afterward, and I just delete all the rest. Okay, delete all the rest. now only these small blue chunks are left. And then I send this compressed version of the context to this. And when you send this query, you still send to a large language model. But the thing is that if you are implementing a long chat session, you have to repeat this. You don't have to repeat the context, long context 10 times. You can just show the, because in large language model, you have to keep adding this context back in every single query. So now you reduce the amount of context you had to add to every single API call, and that's how you can reduce while increase the precision of the answer. So it's compressive, contextual compression. Now, so I don't have an example for the actual implementation, but you could imagine how you write the prompt. For instance, I will say something like, given the set of documents as follows, and the query, identify the parts of each document most relevant to the query up to 20 words and generate the result. And I'll take that response, add back to my prompt, something like that. And then I have a smaller version. Okay? Now, can you also think about, what if you want a multiple query? Can you do that? Can you combine? Think about how you will combine multi-query and this contextual compression. Can you do that? So how many, you will call the large language model again, or you could incorporate into the same prompt. You compress, you will still have to just add one extra step. You still follow two steps, and then another step. Anyway, I haven't really thought through this. Okay, now I have my last one. I want to cover about advanced techniques. Similarly, I will start with the user sending a query. So the query, when humans submit a query, we tend to be very short. We say only very few words. But sometimes I use those words to retrieve a document. And one way we could increase the amount of information in the query is so-called hypothetical document embeddings, meaning that as a query to the large language model first and ask the large language model, hey, can you guess what the document will look like in the result? You make a hypothesis. So for instance, the query is that write me a resume to apply for graduate school in the United States. That's my query. And I send it to large language model saying, hey, can you guess what that resume might look like? And so it's going to generate a possible resume, but this resume is going to be very, very incorrect in terms of content. In terms of structure, maybe not too bad. You still have a work experience, employment, education, and so on. So, but this would has structure, but not the right context. But then if you send this one to your large database, then you can retrieve a much more relevant. For instance, you have a database of lots of resume examples. So you'll be able to find 12, 17, 12, 13. There's a lot more similar to this one. Okay, and then you put all this thing together to large language model. A large model will generate a new resume that has a structure and also have a better context. It's called hypothetical document embeddings, and they get it just. But anyway, so there are other techniques like that. But in general, it all comes down to the end goal is you want to have a query, some context and prompt, but you have some other way to help use language model itself to help you improve the query or document, for instance, summarizing it before your final answer or ranking them before your final answer. Or sometimes you even use language model to improve your prompt. Can you make what is a better prompt to make you say less, explain less? That can make some suggestions as well. And then at the end of the day, you keep experimenting, trying different combination of these techniques. You test it and see whether eventually this template gives you the best user experiences. And after that, you also consider things like cost. What if there's so many traffic? Can you reduce the amount of traffic between large language model and your application? Can you reduce the amount of token you have to send? So there are some consideration in practice now that you know. Eventually, they all share the similar characteristics about prompt, context, and query from the user interface. Okay? Now I have about 5 minutes left. I can tell you a little bit behind the scenes story as I'm developing my lecture over the years. I like to draw and show this on whiteboard. So this many semesters ago, I drew this neural network on whiteboard to show that wait times input, you get linear combination. You add bias, you get this output, but you get the activation, you get final output. And you pass this output to the second layer of X. So it was good to practice calculating by hand. But as you can see, at this point, I did not have the stackable matrix system. So this, even the just two layer, also only 4 numbers, but it already occupy a lot of space. So I learned from many years of improving my drawing. So this is the initial ResNet result, and there's many different matrices and documents. I still have at the time I didn't have the stackable matrix, so it is very different to compare. Even compared to the previous example, they do not share a similar style until I have this matrix multiplication. So now I can tell you this box in the very ResNet diagram. You might see this in the ResNet paper. And so this box does is this times this get this. And what this box do is this times this. But when you add it together, is about this times this, you get this. Where I'm going to go back to my tablet to draw for you. So this is this and this, you get this. Okay, and then use a different color. Afterward, this and this, and you get this one. Okay, so that's what the ResNet does. When you think about the herd was skip connections, residual network, that's what the math does. I really like this math because ResNet paper is the most cited paper ever in deep learning research by far. You check #1 cited paper because it's such a unique concept that allows us to go really deep to hundreds of layers. Without this, now this ResNet connection everywhere in the deep learning architecture, you cannot not have that. It's always there. And so this is my transformer story that initially I have this strange drawing going very differently from what I have now. What I have now is this matrix form. Another thing is in the traditional transformer architecture, you kind of go up and come down, go up again. So I realized one day if I flip it upside down, I can use this matrix multiplication representation. So once I flip it upside down, I could show this is a tension, and this is another layer, and this softmax feed forward and output softmax and get output. So this usually takes me a couple semesters, a couple lectures to go through the whole thing, but I'll give you a taste, the example of the evolution behind the scenes story of how my sketches evolve. The last sketch I'm going to show is the probably the last sketch is the scariest sketch of back propagation. And because it's so scary, I think my PowerPoint broke. I cannot show you. So I apologize. And okay, so anyway, maybe I use the time to tell you something else instead. I want to bring you to byhand.ai website. There I have my entire collection of the deep learning examples that I have developed and shared so far. So I have advanced exercise up to 28. So I covered Fourier transform, LSTM, sparse autoencoder, variational autoencoder, deep RNNs, SVN, and so on. But if you are only new to deep learning, you can also follow my workbook that starts from the beginning. So the workbook take you from dot product, matrix multiplication, linear layer activation, and so on. And so an artificial neuron, batch processing, for instance, now when you get to this far, you can get to see that this is an example, you keep stacking out the matrices, and you can get this multi-layer. You can see how that correspondence between multi-layer neural network and the stack of matrix multiplication here. And in this case, this is a workbook I specifically designed for beginners. So only 1 or 2 value you have to fill on every single exercise, but it will help you build the very, very foundational intuition about the math of deep learning architecture. And once you have that, hopefully you could go on to read some of the advanced one. So it does cover a variety of projects. The residual languages cover, okay, actually I can show you the scary backpropagation. So this is a backpropagation one. So go down and come back up and figuring out all the numbers. Okay, so my purpose of sharing a lot of AI by hand exercise is not that I expect my student to really be able to calculate everything. There's no one can calculate this. And I shared a lot of time when I share on LinkedIn, and people will pointed out my calculation error, and then I will thank them, and I will say that it is evidence. This is done by human, not by ChatGPT calculation. And my purpose of sharing this is to show that deep learning is not a black box. It's actually matrix multiplication. So students should not be too scared to study deep learning. There's something, if you can calculate by hand, even just by one cell, you realize that is not a magic or a mystery. And hopefully, we would like to learn more architectures. Okay, so I will stop here and also take some other questions from the audience. We also collected some questions from you before the session. We can go do that first.
So please give a round of applause to Professor Yeh. Thank you.
Okay. Maybe ask the audience questions first.
Okay.
Okay. So how many of you who took machine learning or deep learning class when you were a student? Okay. And who took classes from Module Labs, AI classes? Some of you?
모두의연구소 커뮤니티에서 활동하신 분,
Yeah.
혹은 강의를 들어보신 분.
Okay.
Okay. 소심하지만 이렇게 들어주시는 분들이 계시네요. 감사하게.
Okay. All right.
Right.
Good.
Thank
Okay.
you. So let me guide you to this cute little camp chair. This is our cute little camp chair. Could you come here in the middle? We have our special moderator here.
It's nice to have some fried chicken here.
So we have a special moderator here today. He is the education facilitator of our Module Labs AI School, IFL. Since he specializes in computer vision, we're having him as a moderator today. Before to start with the Q&A session, while you're considering your questions, I'll start by reading the first question from registrants. No Ha-il. She participates in online. She has 2 questions. If you're there online, please wave your hand. Number 1, why is it important to calculate deep learning models by hand?
The answer is, the question is, why is it important to calculate by hand? Imagine when the electricity is out, when you are in a remote island without access to technology, so you have to calculate by, just kidding. I think the real answer is, again, about gaining confidence in your ability to understand deep learning. If you can calculate just one step or one value by hand, we realize you can learn, you are better than the machine. The machine is just doing simple calculation, and then you will not be afraid of working with deep learning architecture.
What do you think about it, Kwang-seok?
Should I say in English?
You can say Korean. If you say in Korean, will I translate into English? Let's see.
Maybe can you speak both in English and Korean so that Professor Yeh can also understand?
오케이. 네, 안녕하세요. 저는 모두의연구소에서 컴퓨터 비전 교육 운영을 담당하고 있는 박광석이라고 합니다. 네, 저도 그 안에서 벡터들 계산을 하는 데 있어서 정보가 어떻게 흘러가는지를 파악을 할 수 있으면은 모델 아키텍처를 이해하는데 더 쉽게 이해를 가져올 수 있다고 생각을 해서 동의하는 바입니다. I just told we can calculate vector and we can see how information flows into models, so it will be much helpful to try it by hand.
Thank you.
I can tell you a small story. When I tried this first semester, and I asked my student to calculate whole architecture, everything is blank, and my student didn't do well. They made me realize so if I need to show many answers, but only leave 1 or 2 blank. And because my goal is education, you only have to do 1 or 2 values, you can get the idea. You do not have to calculate everything. I hope that makes sense. So my second semester students happier.
Thank you. Do we have questions from the audience here? Not yet. Please, one question by one person will give even opportunities for the participants. Please use the microphone so that we can use the translation system and let the online participants also hear what the question is.
All right.
If you can both speak in English and Korean, please do so.
Maybe, because I cannot speak any English, but anyway, I'll try. Okay. Actually, I have a lot of questions, but she just said that we only have to ask one question. So, I have a question about the rack. By your explanation, I have a feeling that if we increase the length of the query, then we eventually encounter inevitable the curse of dimensionality. That means if the length of query gets bigger, then the difference between, because we are using the cosine differences, or cosine distance, that means if the dimension gets bigger and bigger, the difference between each answer or candidates can be smaller and smaller. So, the common sense says, well, if we increase the length of the query in reg, then maybe we will have a better answer. But actually, I'm worried about if we increase the length of the query, then we will encounter the less of the discriminative answers. We all have the very similar answers at the end. So what do you think of increasing the size of the query in reg?
So is there... We got an update for you. I'm going to come back to my computer. No. To just see where the presentation is now is working now. Okay. So let's review. How do I go back? Here. Okay. So let's review the claim, the statement that if we increase the number of tokens, does the dimensionality increase or not increase? So look at this example, going from word vectors to sentence vector. If we have one more word, what happened? So we have one more here, right? And with another word, we have one more here. And then we have add 4 here and 4 here. So the dimensionality does increase using concatenation. How can we not increase the dimensionality? We can use the second method, average. So we use this method. If we add one more token, do I have to change the green thing? The green thing is still the same. And change another query in the before, all the same. So one of the things about being able to compute sentence embedding is no matter how many words you have in your sentence or document, you always get 4 dimensions, or 512 dimensions is a common one, or 768 dimensions. You do not change. And there's one thing that does change is to you consider the transformer architecture, which I did not cover today, but let's just try this. Maybe I show this. So the transformer architecture, if this is kind of, okay. So this is attention matrix when this is 5 different tokens. So 5 tokens, 5, 5, and get another 5 here. Just I didn't get into detail, but this, you can visualize this. So I will ask my student what happens if you add one more token. So you have one more column here. In order to get another column over here, so you have to add another row here, another column here. So it is you increase in 2 directions. When we increase in 2 directions, we use the word quadratic increase. So now imagine you have 5,000 tokens and 5,000 tokens here. And what happened to this matrix? Also times 5,000. How can I get 5,000 tokens very quickly? One way is that if you pretend this cell, you cut this cell into 1,000 pieces. You cut this one into 1,000 smaller cell. This is 1,000 smaller pieces inside the cell. When you do that, you have to do the same thing here, 1,000 times 1,000. So you get this 5,000 by 5,000. So use traditional, basic, original transformer architecture when you increase the context size, this is the problem you run into. So now there's many other advanced techniques you can improve, so you don't have to grow this matrix. So I guess I hope answer some questions. So it's true that adding more context, adding more tokens, dimensionality increase only if you use concatenation. But if you use average, you somehow still remain the same dimension. But you run into this problem. This becomes a bigger problem. Hopefully, there's a bit more technical. I guess I answer in the mathematical level, but in the practical level, people company want you to use large context windows. Why do you think that? Why do you think they want to do that? Guess. Why do you think they want to use a large context? Because they can charge you more money. So they want to encourage you to fit all your data into the prompt, instead of something clever like summarizing your data and sending smaller piece of information. So they have to learn how to do that on your own. You cannot expect the company to do that for you. Okay, there's a long answer, I apologize, but.
Thank you so much. Yes, we have a question here.
So, dear professor, I feel like I'm really thank you for your explanation about AI and some
You're welcome.
convolution in the network. So I'm curious, do you have any plan in the future when you can explain something like mathematics about common filter, Fourier transform? Because I have a lot of problem with those kinds of algorithm. It's like a black box for me too.
Oh, you're lucky because I just shared about Fourier transform, but I don't have one for common filter. I might do one in the fall since I teach computer vision. If I cover a common filter, I might do a post. But you can check out the Fourier transform post, discrete Fourier transform. So this summer I have more time. I started to challenge myself to develop AI by hand exercises, not just for AI, but for more traditional signal processing. So I did one for Fourier transform. Also try to see, can I explain even more advanced computational concepts, such as quantum computing. So I managed to share one example that I could explain the basic of superposition in quantum computing. So this method is definitely generalizable to other computer science domains.
Does that answer your question? Thank you, Professor. We have a question from online participant as well. Do you manually calculate when researching or reviewing new deep learning models?
Do I manually calculate? So I did manual calculation for all the exercises I shared publicly on social media, and so that's why I welcome error corrections. And so initially I was more conscious that I check my solution many times before I post it. I don't want to embarrass myself. But then I learned that people are quite generous. They don't laugh at me. So I actually liked to point out error, and I just admit error. And it turns out because I share my post as pictures, when I share on social media, I cannot update the pictures. So my calculation error is there forever for everybody to see. And so, yeah, so there's a little story behind this. Then I decided even making error is part of a learning process, that I can tell my student that do not be afraid of making error while you are learning. That's what makes you human. So I'm becoming proud of my calculation error. And if you look at my Fourier, some of my recent posts, even the first value contains an error, but it's too late for me to change. So just let it go.
Thank you. That gives us a good insight. Making mistakes is okay, as researchers or developers or anyone in our Korean society are required to have perfectionism. So we can have one more question from the audience. Yes.
What's your perspective about comparison between fine-tuning versus retrieval augmented generation? So there has been a debate about retrieval augmented generation is better than fine-tuning, or some people prefer fine-tuning. Personally, I prefer retrieval augmented generation, but I'm just curious about what's your perspective about this debate.
Oh, so the question is comparing fine-tuning and retrieval augmented generation, or in other words, RAG. And so let's think about for fine-tuning, what do you need if you fine-tune? You need training examples. So sometimes it comes down to your particular use case. Do you have training examples of your own that you can fine-tune the model? So once you fine-tune the model, you do not have to pay for the extra tokens you have to send in the RAG scenario. And on the RAG side, I like how dynamic and flexible you could make your RAG. It comes down to being creative about writing a RAG. And so we just worked out a few examples. Even when I ask you, can I improve RAG in this way, you can immediately answer. All I have to do is you add extra step to compress, to summarize your query. So in terms of the innovation, it's easier for you to test new ideas in the RAG ecosystem. But the RAG also has a downside that sometimes it's difficult to evaluate. For instance, today the RAG works really well. When tomorrow, when OpenAI change something and the results is completely different, you have no way to know that unless you test it again. So the testing requirement is be higher and unpredictable. Whereas fine-tune, once you fine-tune, with respect to your data set, you can expect the fine-tune model will perform the same tomorrow. You have your own. You have better control of fine-tuning the model. Hopefully that is one perspective about fine-tuning versus RAG, depending on your application needs. What's your preference? Your preference is RAG, right?
Well, it is not my question, but I want to elucidate some other aspect of fine-tuning versus RAG. So in the fine-tuning, first, it costs a lot, and we need a lot of data. And the second aspect of or some downside of the fine-tuning is after the fine-tuning, we, eventually it comes down to the overfitting after the fine-tuning, and it cannot be reversible. So how can you deal with those kind of some downsides?
So you're commenting on the downside of fine-tuning is overfitting, and there's really not a sure way you have to avoid overfitting. So you have your best practices, trying to follow best practices, make sure you have good quality data. Now, the sense is that you want the method, fine-tuning method, algorithm architecture to be simple, and you spend more time to improve the quality of your data. So you rather improve the quality of data. Also, you like to think about how to feed your data in a certain order. That is a lot of discussion, and so then the research on fine-tuning, but also try different pattern of feeding the data because say you have the data, all the textbook from first grade to high school, if you feed your model, it will be not good to feed the high school's knowledge first, because the model might not have the way to understand that. It's almost like training your kid. You will feed them the elementary school subject first, and then build up some basic foundation, and you feed them some other data. So a lot of research and development effort in the AI field is about, in practice, that trying many different ways to feed data, and hopefully you find the best way, the recipe to feed the data, also improve the quality of the data. And let's spend a bit less time fancy architectures that are difficult to scale. You want simple architecture you can scale, but you're trying to figure out the best way to feed data to your model during training and fine-tuning.
Kwang-seok, do you want to comment on this?
Actually, I thought very simple on this topic because fine-tuning costs money. So, and I believe lag is much better solution.
Thank you.
These are really, really great questions. I'm really impressed. Thank you very much for listening.
Thank you very much for your engagement, and Professor Yeh for the passionate.
I want to thank you for being such a wonderful host.
Thank you so much.
She's working hard to organize and make this a possibility, and I want to thank you very much.
Thank you. So as the seminar comes to an end, I'd like to guide you about the survey and the network. So, Professor, please be seated. And, yes, thank you.